Applications of differentiation. Elasticity of demand. Find the elasticity of the demand function. Find the maximum of a total of a revenue function. Characterize demand in terms of elasticity. Elasticity of demand is given as a function of price x by e to the x, given by price by e of the function. Name of the function is e x times the d for the demand derivative of the demand function divided by the demand function. The total revenue is increasing for those values for which e of x is less than 1, is decreasing for those values in which e of x is less than 1. It's maximized when it's equal to 1. This deals basically when how much can you increase the product before people stop buying it. That kind of thing. Elasticity of demand is given by this function. They already talked about that. Next slide. The demand for video game rentals at Clicks Video Games is given by, there's the demand function there, where Q is the number of video games rented per day at X dollars per rental. Find the elasticity of demand function of X. Find the elasticity of 2 and at $2 and $5 and interpret the meanings. Find the value of X for which is equal to 1. What does that mean? Let's go ahead and get started. So to find the elasticity, we have to find the first derivative. In this case, the first derivative is 20. Okay, and there's our demand function there. So our elasticity of demand function simplifies to x over 6 minus x. Okay, then evaluate it for 2. At x equal to 2, the elasticity is less than 1. So that means that a small increase, percentage increase in price will cause an even smaller increase in the quantity demanded. Okay, so in this case here, just a small increase. People will slow down in buying it. They'll perceive it different how they perceive it. Since the demand is inelastic, raising the price of each rental by a small amount will increase the total revenue. Okay. Let's look at the next one here at 5. The elasticity is greater than 1. Thus, a small percentage increase in price will cause a larger percentage in decrease in the quantity demanded. Since the demand is elastic here, raising the price of each rental by a small amount will decrease the total revenue. So you see there, when they increase the price that much, will decrease the total revenue. So for what value at 1, which means it'll be elastic, they set it equal to 1 and solve for. So the best price for the item here is at $3. So you maximize its total revenue at $3. Okay. The demand function gives me 60 rentals per day, and the revenue is $180 per day. So that's the maximum price there. That'll result in the maximum revenue. The maximum price per unit, that will result in the maximum revenue for the item. Now this one here, another example. The demand for Organic chewing gum is given by the demand function here. The Q is the number of packs sold per day at X dollars per pack. And that's the demand function there for it. Find the quantity demanded when the price per pack is $2, $3, or $5. Find the elasticity of demand as a function of X. Find the elasticity at $2, $3, and $5. Interpret the meaning. Of these values of the elasticity. Okay. Find the amount quantity demanded at $2 and $3 and $5. So evaluate D for $2, $3, and $5. So that's the quantity that is going to be in demand. So when the price is $2, that's the demand. When the price is $3, it goes down. When it goes $5, it goes down. So if the price is $5 a pack, there'll be no demand for the chewing gum. Think of this like in cigarettes. At some point, they're going to stop buying them. But you always have a few. Find the elasticity. First, you find the derivative. In this case, the first derivative is -7. So the elasticity of demand function is there. You simplify, that's your elasticity of demand. So, in this case here, the elasticity is less than 1. In this case, a small percentage increase will result in a smaller decrease in the quantity demanded. Since it's inelastic here, it's not really attached to it, then the price of each pack by a small amount will increase in the total revenue. So in this case, it's just a small increase, but small enough that it will increase the total revenue. When you do it at 3, at 2, at 3, you achieve unit elasticity. That is, at $3, the total revenue will be maximized. So that'll be 42 packs. So the demand will give up 42 packs sold per day, and the revenue will be $14 per day. 14 per day. That'll mean 14 packs sold per day. Now we do it for 5. Elasticity is is undefined. So elasticity is undefined since increasing the price can't lower the demand any further, nor can revenue be decreased by raising the price. There'll be no demand for it. The price is too high. Elasticity is undefined since increasing the price won't lower the demand. Nor can revenue be decreased by raising the price. There. Section summary. For the demand function, elasticity of demand is given by this function here. It's inelastic when it's less than 1. With small increase in price, the revenue increases. It's elastic, then a small increase in price, revenue decreases. You have a unit elasticity if demand is equal to 1. If demand has unit elasticity at price X, the revenue will be maximized.